Hello students, in the last session we have discussed about the asynchronous counters. Counters, definitions and all those things you have studied. In this session I am going to explain about the applications of the shift registers. You have studied about the shift registers. You have studied about the shift registers. If your applications of the shift register is one of that one is a ring counter. Ring counter. Yes, it is the shift registers um, applications. It is that one. How does this? Why does this ring counter is obtained from the shift registers? Directly feeding back to the true output of the output flip-flop is data input terminal of the input flip-flop. The If the D flip-flops are being used to construct the shift registers, the ring counters, also called as a circulating registers, can be used. For example, this is a ring, it is there. Yes, this is the circuit. 000 is a tap. Next number of that one 001, 010. Like that one, it can complete the one cycle for that one can be used in this registers. That can be used. How does this one can be studied in this ring? Right. This is the first. I'm going to give the clock is 0. The first count is clock is 0. D is also 0. First one, if you are 0, the clock is 1, 0. Obviously the 0 will come. All our zeros will come. That is in the reset. Yes, the D flip-flop being used to construct the shift registers, the ring counter. The ring counter, also called a circulating the registers, can be constructed by the feeding back the Q output to the output flip-flop back to the input of the D flip-flop. Means that one, this is the way of constructions. This is the feedback. Yes, this is the feeding back to, yeah, feedback means what is that? Output is given to the input, that is called it as a feedback. Means you have studied in the operational amplifiers the meaning of the feedback, right? At the same way, if you are studying in the ring counter, whatever they giving the, for example, I am going to take the 3-bit data. 3-bit data means it is a 0000, it is there. In that, the next data is 0. Next data I am going to take that one. Yes, next data I am going to take that one. First one is a 0000. I am going to take that one. Next is a 100 can be taken. Next, complete this 1 is shifted to here. That will come 010. Next, this one comes to here. 001 will come. This one is enters to the device. This is a 000. Yes. Next, I am going to give 01110. Continuation for the ring. It is circulating. It is called it as a ring counter. It is called it as a ring counter. In the 4-bit data, it is a 4 flip-flops are there. 1, 2, 3, 4. first count is first count is first clock. First clock, it is 0 0 0 0 0 will come. Next clock is 1 of the clock. 1 is enters to here. Output means what is the D of that one? 1 will come. 1 is comes here. These all are zeros. These all are zeros comes. Then first clock. Second clock. Second clock. This 1 will shift to here. It is a 0. 1 0 0. Next clock 0 0 1 0. Next third fourth clock 0 0 1. Fourth clock is comes. Fifth clock. Fifth clock, what will come? Again start from the first. Next sixth. This one goes to here. Like a repeating in the ring, it is called as a ring counter. The flip-flop FF0 is, this is a FF0 is initially set to the logic 1 state. All the flip-flops are reset to 0. Correct? The counter of the output is, before that 100 it is there. With the first clock pulse is 1 gets shifted to the second flip-flop. I have explained. The output of the counter output becomes 0100. The third shift of that one counter is clock pulses. The counter outputs will be the 0010. Next is a 0001 will come. With the fourth clock pulses, counter output will be the again becomes 100. The count of the cycle repeats of the subsequent clock pulses, that is called it as a ring counter. That is called it as a ring counters. The waveform can be drawn like that one. I'm going to give the clock it here. Clock here. Q0 is a first is a high, then low, then high, then low. The Q1 is next clock pulse is high. Other next one is a other next clock one is high. Q3 is a other clock pulse will high. Yes, the counts of that one, first it is high, second it is high, third it is high, fourth it is high. When it is the high, then it is the next count of this one is a next this one is high, next this one. It is a continuously, it is a processing like that one, can be call it as a ring counters can be call it. This is the call it as a ring counters. The waveform of the this type of frequently used in the control section of the digital system. They are ideal for controlling the events that must occur in a strict time sequence. That is event A. That is event A. Then event B, then C, and so on. For instance of a logic diagram in figure shows how to generate the reset, read, complement, and write. The functions of the reset means comes to first state or a before state. It is a 0. Read. Read the instructions. Complement. Whatever giving the A is 0, complement of that one equals to high. Then write. Whatever the signals read that one, you have to write it. The frictionless set of the control signals as a set of control pulses that occur one after the other sequentially. Sequential in the ring. There are however the problems with such a ring counters in order to produce the waveforms shown in the figure. The counter should have 1 and they 1 to 1 in the 8. The changes in this occurring the naturally when power is first applied are very remote indeed. If the flip flop should be all happens to be in the reset state, in the reset state can be explained. If the flip flop should be all happens to be reset state when the power is in the first applied will not work at all, means it is a first can be first can be reset, read, complement and write. Reset means 0, read the instructions, 1 will you give that one, complement is 0, then you have to 0 write it here in this equations. This is the ring counter of that one in this. Yes, in the ring counter can be applied for that one. In the 2-bit ring counter is 2-bit ring counter is first is a 0 0, next state is a 1 0, next count is a 0 1, next count is a 1 0, next count is a 0 1. It is continuously it is in the structure, can be called it is a ring counter. In the 3-bit data, cycles is first cycle is 0 0 0, first cycle 0 cycle, first cycle is 1 0 0, second cycle is 0 1 0, third cycle is 0 0 1, second, third, next fourth counter is a 1 0 0. It is a fourth and the first counter is a same. It is continuous in the ring structure, can be called it as a ring counter. These are the applications they have used. First one, clocks are using that one. This is the clock for that one. First clock, Q naught is high, then low. Next clock is a high for the Q1, Q1. Q2 is a next clock is high. Again other next clock is this one is a high will come. This one is high will come. Once this is a decreasing, that next one is a this one is high. In this next section, this one is a high. This is the continuous waveform generated in the ring counters. This is a ring counters by using the application of the shift registers. Yes, this is the way to express in the 3-bit and the 4-bit. This is a 4-bit counter. You can use the 3-bit counters also use for that one in your way. Yes, first clear the concept clearly. Okay, this is the way to express the uh, ring counters can be used. In the next session, I am going to explain about the Johnson counter. Yes, thank you. Please watch our videos regularly and understand the concept clearly. Okay, these all ring counters can be used in the D flip flops. D flip flop using that one. The truth table of the D flip flop you should remember very carefully. That is very important. D equals to clock is 0, the output Qn plus 1 of the next state is 0, or there is no output for that one. If the clock is 1, just a minute, clock is 0, D flip flop is 0 or 1, X 0 or 1, whatever give that one. It is the no judgment for that one. Clock is high, 0 is a D, 1 plus its output is a reset, and 1 is a set. In the output will come for the D flip flops. This is the 1 will come for that one. Clock is 1. Obviously the output will 1 comes here. That one is goes to shift to the next counter. This is the 1 and 1 it is there. This one is output is 1. Remaining all are zeros. Remaining all are zeros because of the I'm going to give that one. This clock is a 0 can be used for that one. Next is a this is the this one is shift to the this one is shift to here 0 1 double 0 will come. This one shift to serial in and serial out, like that one will come. Like again one comes here. This is the continuously the in the circulating the rings for that one. That is called it as a ring counter. Please clear the concept clearly. Thank you. Please watch our videos regularly.